Hi, everyone. Welcome to this webinar hosted by ASE and the ASE Education Foundation. I'm Jennifer Holland, Assistant Vice President of Marketing at ASE. I want to welcome today's technician audience. The mandate for tire pressure monitoring systems has been with us for almost 13 years. A lot has changed since the first systems hit the road, so today's session should really help in bringing you up to speed. I'm pleased to introduce Sean Lannoo, Technical Training Supervisor with Continental Corporation. Sean will be presenting TPMS 2020. It's not just the warning light anymore. Take it away, Sean.
Good afternoon, everybody. I am glad you are here on your Friday afternoon. We're going to close out the week, like Dan said. Thank you, Jennifer. And we'll get started here. Hopefully everybody can see my screen. I think we can. And my name's Sean Lannoo. I'm Technical Training Supervisor for Continental. I have been with Continental for almost 22 years. And believe it or not, I've been doing TPMS for about 16 years. Never did I think 16 years ago that I'd still be doing a technology or a safety item on a vehicle that is still here, for one, and is constantly changing. So with that said, let's get started. I'll talk real quick about Continental, and then we'll get into TPMS. So Continental consists of 3 technology groups: the automotive group, which consists of autonomous mobility and safety, as well as vehicle networking; the rubber group, which encompasses our tires. I'm sure you maybe heard of Continental tires, and also ContiTech, the belts and hoses that are out there. Then we have our powertrain group, Vitesco Technologies. Continental's TPMS, we design, manufacture, and supply the complete OE TPMS system, not just the wheel sensor. In '98, we began developing TPMS products. In 2003, we became an OE supplier of direct TPM systems and sensors in North America. 2005, we introduced VDO branded replacement sensors to the aftermarket replacements, the part houses, everywhere like that might be using these. And maybe many of you have seen these sensors. And in 2018, we have produced over 300 million sensors as of 2018. So that's a lot of sensors, and we're not the only sensor manufacturer out there. Obviously, you know that. There are many other sensor manufacturers. So just think of the number of sensors that are out there on the road. So let's quick cover the mandate. Many of you are probably familiar with this. If you're not, and you have questions of why, please ask those, but we'll briefly touch this. And again, if you have questions, go ahead and ask those. But the mandate was a phase-in over a 3-year period of time. Model year 2006, 20% of all vehicles sold in the US with 4 wheels and a gross vehicle weight rating of 10,000 pounds or less had to have TPMS. Model year 7, 70% of those vehicles sold in the US had to have TPMS. And by model year 8, or September 1st, 2007, it became 100% mandated. And that mandate, there was basically 2 levels of requirements to this rule. 1, it must detect and provide a warning to the driver within 20 minutes of the pressure of 1 or more of the vehicle's tires, up to a total of 4, falling 25% or more below the recommended cold inflation pressure. This was illuminated solid as a low pressure warning telltale. It's displayed as a cross section of a tire with an exclamation point inside. That was the first requirement. The second requirement is that it also must indicate a system malfunction. As a MIL, or a malfunction indicator lamp, it must flash indicating the system has malfunctioned. top-down view of the vehicle is not required, but this shows the 4 pressures displayed as a overview or a bird's eye view of the vehicle. And this is becoming more and more standard on many vehicles. There is also a make inoperative provision to the Motor Vehicle Safety Act. It states that this system cannot be knowingly disabled by an OEM or an aftermarket service provider. You see that picture there showing a piece of tape covering the light. Many of us have seen this in the past. A picture of a family member or something like that covering that light so that we don't have to look at it. As technicians, we cannot do that. It is violating this Safety Act. So what is a telltale? It's a device or object that automatically gives us a visual indication of the state or presence of something. And in regards to TPMS, the telltale is displayed after key on. First, a bulb check, like many other telltales and the gauges, approximately 3 to 5 seconds. After that, the light will either go out, remain on constant, which means there's one or more low tires, or it will flash. TPMS flashing with a mill is only required to flash for 60 to 90 seconds, and then it will go on constant. This means there's a system problem. Most of the time, that system problem is sensor related. Yes, there could be problems with modules in different parts of the car that relate to TPMS, but most of the time, it is a sensor issue. And this cycle will repeat every key on. It'll repeat this exact cycle until the problem is fixed. I'm sure you've seen a vehicle placard. If you haven't, here's one. They're located in the driver's door jamb of all late model vehicles. And this is the number that they use to figure that 25% below. Now, we'll talk real quick on 25% below because most manufacturers don't do 25%. They're in the 12, 15% range. So if we take 32, for example, 12% of that is right around 4 PSI. So that means at 28 PSI on many vehicles, that light's coming on. 4 PSI is really nothing. We can easily see that loss on a cold morning after a warm day the day before, or working in a shop on a vehicle where it's 60, 70, 80 degrees in the shop, maybe 90 in the summer, or 100, 110, and it gets down to 60 or 70 degrees in the morning. That's 30, 40 degrees difference. We lose and gain about 1 PSI for every 10-degree temperature change. And we lose about 1 to 2 PSI every month. So think of a vehicle working, you're working on a vehicle and you put 32 PSI in a car and it's 100 degrees in the shop. That vehicle goes outside, temperatures equalize, sits in the driveway or the garage in the morning. It's a cool morning and now it's 70 degrees. That could be 30 degrees difference or 3 PSI. We're very close to illuminating that light. Go another month, and now that light starts coming on every morning that it's cool. So technicians need to be aware of temperatures outside versus inside. You go into the Northeast and the colder regions, they can see 40, 50, 60 degree difference from inside their shop to outside in the wintertime. Makes a big difference. You definitely don't want to work on a car today in your shop that's 70 degrees and it's 20 degrees outside, and you put in the cold inflation pressure that's recommended off this placard, and they go home, it's 50 degrees colder that morning, and now they're 5 PSI low and the light's on. They come back. It takes time. So we have to be more aware. Think about that. So maybe you add 3 or 4 PSI on these really, really cold days so that by the time it gets outside and equalizes, you're very close to that placard pressure. It's just a thought to think about in the fall and winter months when there's a huge temperature change between outside and in the shops. So system types. I'm going to talk about the two types of systems, and then later on we'll talk about the types of direct systems. There's multiple types of direct, but there's basically two ways to determine that manufacturers use to determine a low tire. So indirect, it's a system that operates in conjunction with the wheel speed sensors, the ABS system, different things like that, along with other signals and some software processing. And this system can indirectly determine if a tire up to 4 is underinflated. And that's the key word, indirectly determine. Indirect systems do not have sensors inside the tires. They detect the possibility of a low tire by comparing wheel speeds via the wheel speed sensors. They're not as sensitive to changes in tire pressure. Unable to read the pressure when the vehicle's sitting still. Has to be moving. We have to look at that signal we're getting from the wheel speed sensor. It is very low cost to the manufacturer, and many manufacturers had to abandon this type of system to meet the federal mandate. One of the weaknesses of the older direct systems is that it may not turn on the warning light if all tires are equally underinflated. So going 3 or 4 months, we lose 3 or 4 PSI. If there's no other pressure loss other than natural, all the tires are going to be about the same. And on some of the older systems, it would not detect a difference because they're all rotating the same. Most of those are gone. Cars are still out there, but manufacturers are not using that type. New systems, though, are taking advantage of better wheel speed sensors, maybe not counting pulses, but timing the distance between pulses, different things like that. And if you haven't seen them, here's some wheel speed sensors. Continental manufactures many different wheel speed sensors, but these are used, and these are the key component to an indirect system. If you have one of these fail, sure, your TPMS is not going to work, and we kind of, if one fails, there's ways to look at that, and they use some software to determine if maybe that tire's not low, maybe it's a failed piece. But either way, if you have one of these fail, as you know, most of you probably know, you're going to have other issues, other trouble codes, other lights that come on, other systems in the car that now are not going to work properly. TPMS will just be one of those that could be eliminated as far as functioning properly. And with an indirect system, most of them have some sort of a reset button or a software selection for recalibrating the system. The reset is typically required after changing air pressure in one or more tires, replacing or servicing a tire, rotating the tires. These all require reset. And on some of the older systems, it is recommended in the owner's manual and in service manuals not to just replace 2 tires or 1 tire, but rather all 4, because even 3, 4, 30 seconds of tread depth difference can cause this light to come on. So newer systems are better, but there's still vehicles out there with these types of systems in them. And here's an example of the vehicles with indirect systems prior to September 1st, 2007. That was the mandate date, model year 2008. So September 1st, 2007, you see a list here of many vehicles, makes, models, and years that were using indirect systems. After September 1st, 2007 through model year 18, this is what we have. A lot of these followed in 19 and 20 as well. But this list shows what we had through model year 18. A smaller amount, but they're still there. Now, some of these manufacturers use indirect on their lower platformed vehicles, and then their higher platform or highline vehicles, they might add direct systems to that vehicle as an option or with a package. One thing to note here, Mazda originally was direct. You'll notice by the dates there, they went to indirect. They have now switched back to direct systems 100%, starting with their model year 18, 19, depending on the model, 18, 19, they've switched back to direct systems. Now, direct systems, it actually uses a sensor in each tire. That's really what we're going to be talking about the rest of this presentation. And that's most of what we see in the shops when you see that there's a problem with TPMS. But these physically measure pressure and report it to the vehicle to display a low tire as a telltale, and sometimes, depending on the vehicle, the actual pressures. So a direct system uses air pressure sensors inside the tires. It measures the exact pressure of the tire. It reads the tire pressure when the vehicle is standing still. Unlike indirect, it will turn the warning light off if all tires, or will turn the warning light on if all tires are underinflated by a similar amount, because each one is measured individually. They are far more costly to manufacture, far more costly to service, but they are far more accurate as well. And they are capable of displaying pressure by position to the driver, which we see in more and more vehicles today. One thing to note, 95% or more of all TPMS equipped vehicles in the US are direct. The sensors. I'm going to show some older sensors, and then we'll talk about a timeline for Continental, and then show you what is out there today and where these could be going. So early sensor types. GM had this style that was used on Cadillacs and Corvettes. Color had to be in a specific location, and it was also directional. If you can see the arrow on there, it had to point in the direction of rotation. So doing a tire rotation, sometimes on certain vehicles, you might have to break down the tire and either move tires or move sensors from different wheels rather than actually just rotating the tires. Chrysler used a sensor through 2012 that had a little strap, and you can see right there in the highlighted area that was easily broken if not properly handled. This would cause a weak signal to the receiver, but a TPMS tool at the tire wouldn't be able to detect the weak signal. It would say that the sensor's okay. So many vehicles would have trouble codes stating a weak or no communication from one or more sensors. When you drive it, customer comes in, you got a trouble code. But after a while, or moving slow or sitting there, it would pick up the response from the sensor and the light would go out. This is a reason it is important to have TPMS tools that can read these trouble codes. So you can pull these codes and see what the code is. And then the banded style from Ford, very common, used on almost every Ford through model year 2010. Has been discontinued, but still can be used out there as a replacement sensor. They're still out there on many vehicles. And I'll probably say it a couple times, but these sensors last about 7 to 10 years, all of them. 7 to 10 years is a typical life cycle of a sensor. So these sensors, model year 10 was the last year. We're coming up on 10 years, but they're still out there. This was mounted, well, it came in 3 colors. You can see there, black, blue, and green. And green was high pressure for the trucks, and then black and blue were passenger car sensors. It was mounted using double-sided tape on that silver cradle, and then a band that was strapped around the drop center of the wheel, and it was mounted in the drop center, 180 degrees from the valve stem. This sensor was also directional. So one side had to be to the outer edge of the wheel. This tape would deteriorate over time, and the band can get loose from expanding and contracting, and it would cause that sensor to slip. And then when we would go there and break down the tire, if we're not paying attention, you go to break down the bead and bam, snap, hit a sensor, break it off. They're still about $125 a piece. These sensors, though, can be replaced by Continental's REDI-Sensor and many other aftermarket sensors that mount to the valve stem rather than a banded type sensor. Here are two sensors currently in use by Continental today, and other manufacturers are using similar designs. We might see more designs in the future, and I'll show you some of those in a few slides. But this is a clamp-in style and a snap-in style. So a metal stem and a rubber stem. Metal stem came around not only because of, but one of the key reasons it was metal, because it's stronger. It bolts in or clamps in. And the bodies of these sensors were pretty large enough with centrifugal force spinning that wheel at 70 miles an hour, the force pulling on that sensor, if we had a rubber stem behind it, could actually rip it right out of there. So it was more of a speed rating than anything else. There were other factors, but that was the biggest one. Now, as sensor bodies get smaller, we're able to use, and you see out there, more snap-in style stems. All sensors have a hole in it. That's what measures the pressure. And this hole can be damaged. It can become plugged. Using tire sealants can actually plug these. Think about, what is a tire sealant for? It's to plug a hole. This is a hole. Could it be plugged? Yes. So we have to be careful of the tire sealant in there. Clean these off. You can't stick anything in those holes, because right below that, about 2 millimeters, is a diaphragm that's made out of, I think it's glass, and it can easily be damaged if we poke something in there. You can wash it off with your hands, clean it off, whatever. And the other thing is, tire sealant won't hurt the sensor, but it could damage the size of the hole or plug the hole. We can wash it off, clean it off, but a lot of people, when they grab tire sealant, they're not grabbing one can and reading the directions and it says use half the can or whatever the directions say for that typical brand or that brand. A lot of people buy 2 or 3 cans, because not only are they trying to plug the hole, they're trying to fill up their tire with air as well. So they're using the canned air with the chemical in there that could plug this hole. We just have to watch that and be careful. So here is a timeline of Continental OE sensors. And like I said earlier, there are many other manufacturers. I know these because I work for Continental. So in 2003, we had the TG1B. It's just our code or our number for this design. It was one of the first designs from Continental, and we use this for FCA, Chrysler products, Jaguar, Land Rover, Volkswagen, Audi. In 2004, we came out with the TG1C design. It was a smaller, adjustable stem, more advanced sensor, and Hyundai, Kia used it, Nissan, Volvo, Honda, Tesla, BMW, they all use this type of sensor. And if any of you work on tires, I'm sure you have seen these out there. In 2013, we introduced our TG1D design. It was a snap-in design with a press clip and used on FCA products, Nissan and Mitsubishi. In 2017, very similar to the 2013 product, but it had a bolt or a Torx head screw on there to attach the stem. It wasn't a press clip design. It was typically mostly used for Jeep and products through Chrysler that they wanted a screw rather than a press clip design. And then we came out with, in 2019, the TG1D Evo. It's a much smaller snap-in design. New Mazdas will have this. Nissan and Acura are going to use this. If you haven't seen it, you will start seeing this design. It is more balanced. It's a lot smaller. The weight of the sensor actually equals or is very close to the weight of the stem. So when the wheel is spinning and centrifugal force is pulling on that sensor to rip it out, centrifugal force is also pulling on the stem. Well, they're equal in weight, so it basically balances it out and it doesn't move so much in there. Some of the sensors that are out there in the marketplace, the body is so large and so heavy that it raises that sensor up, causing pressure and causing an opening in the stem where the hole of the wheel is, which causes a leak-in point. And I have even seen some sensors so heavy that because of the centrifugal force, they actually flip over in there. And on some vehicles, which I'll show you towards the end of the presentation, that can cause confusion, but no lights on the vehicle. So we'll talk about that one later. And then finally, the future. What does it hold? We don't know. TPMS has been changing so much, but Continental does have EDIS. It's Electronic Tire Information System. And you'll see other manufacturers with something similar to this out there. It is not used in US by any OE or any aftermarket supplier, but it is used in Europe in the aftermarket. Branded REDI-Sensor, we have it out there. But like I said, other manufacturers have it. It's also used in commercial vehicles, larger trucks. It's actually very small for the passenger cars. And the rubber mount there becomes a service kit, just like all the other sensors have. So if you have to change a tire, you pop out the sensor, you put the new rubber service kit in, snap the sensor back in, and away you go. I got a slide on that in a little bit as well. REDI-Sensor, real quick on this, I won't spend a lot of time on this, but this is also what we have, and this is our aftermarket replacement sensor. Those other ones I showed were all OE. This is aftermarket. It's a multi-application sensor developed with our OEM technology. It's a solution that's supported by a rock-solid, reliable TPMS system manufacturer. It's a truly credible aftermarket solution. It's 100% OEM validated, designed to follow the OEM Relearn procedures. It's simple for shops and technicians. There's no programming needed, no pre-program. It's pre-programmed and ready out of the box, just like an OE sensor. Very close to the way OE sensors are designed. It meets all federal mandates. And if the vehicle is auto relearn, this is auto relearn because it follows the OE procedure. REDI-Sensor, like 20/20 vision, it's the clear choice. So now let's talk about frequencies of sensors. TPMS sensors transmit data to the vehicle. They do that with a carrier, and that carrier is a frequency in this case. And the frequencies used today are 314.9, 315, and 433. 314.9 is used by GM only. Close enough to 315, so most of the sensors that are out there that are 315 carry or handle the protocol that GM uses on the 314.9 sensors. Typically, it's the same as your key fob frequency, and that's actually where this frequency was started from. It didn't start with TPMS, it started way before that. Our receivers in the cars typically operate on these frequencies, and usually, most of the time, the sensor frequency and key fob frequency are the same. So if you need to determine sensor frequency and you have the capability to test a key fob with, for example, a TPMS tool, you can test this frequency or this key fob. It'll tell you what the frequency is. And then if the parts house needed to know what frequency you needed, then they can determine what the part number is for that replacement sensor as well. Sensors transmit in a timed intervals based on rotation and other based on time only. So some do time only, some do time based on rotation. Sensors that transmit in timed intervals on rotation can be thought of as having modes, like you see there: drive mode, park mode, sleep mode. Timed sensor transmissions will vary based on rotations, and this helps conserve battery life. Most aftermarket replacement sensors behave in this manner. Some sensors, or most all sensors, have to transmit a unique sensor ID. It's also printed on the sensor. It's usually printed or used by the vehicle in an 8-character hexadecimal format. Tools have the capability to convert to a decimal, but most vehicles, like I said, store this as a hexadecimal format. Some vehicles only use 7 characters, and even newer vehicles, a few, require certain characters to be in specific locations. So our tools have to be capable of reading this. Tools need to be able to update or load this into the vehicle. I know maybe some of you are familiar with, let's say, a Toyota Relearn. Toyota Relearns, typically you trigger sensors, you get the IDs, and then you hook up a Toyota scan tool, and then you manually type in those IDs. With a TPMS dedicated tool, the tool does that work for you. You trigger the sensors, the tool stores the IDs, you plug the tool into OBD, and it writes or uploads those IDs to the vehicle without having to worry about copying them or writing them down. And if you've ever worked with hexadecimals, 8s look like B's, D's and 0s look the same. It can be difficult, and reading them on a sensor, as you can see here, is not that easy. They also transmit pressure, obviously, that's why we're here, temperature, sometimes the battery status, depending on the protocol, depending on the manufacturer, and possibly other information soon, which I will cover with an EDIS style sensor. So there's many ways to determine sensor frequency. You can use a TPMS tool to trigger the sensor. Most TPMS tools will display the frequency right on the tool. You can read the sensor frequency printed on the body of the sensor, if you can read it. Sometimes it's small, it gets worn off. Plus, you have to break down the tire and wheel assembly to see this. Sometimes you can call a dealership and get it with a VIN, but not always. Depending on the vehicle make, sometimes they don't record this, and because they change based on different platforms of vehicles. Key fob test on the tool, like I said, that's very easy. And you can visit the FCC ID website, type in the ID if you can read it on the sensor, go to the website, and it'll tell you who manufactured it, what the frequency is, pictures of it, all kinds of stuff. So if you ever want to find out what brand or what manufacturer or who did or what the frequency is for a sensor, type in the FCC ID on Google and you will easily find this information. A lot of information is found on this website. So let's talk about the different sensor types. You have the OE sensor, original equipment sensors. They usually have one protocol and one ID already stored in it. But there's hundreds of part numbers, yet they work right out of the box. They can be a little more costly, not always stocked at parts houses, and it's recommended to follow the OE Relearn procedure when changing these. Very easy there. Programmable sensors, they are delivered blank. They require a capable tool, and that could be an additional tool. And wherever you're getting these from, that parts house must know if your shop or you have the proper tool to program the sensor. If you don't have the proper tool, we can't program it. You think something's wrong, we send it back, when really it's the sensor needs to be programmed. Some can only be programmed in a specific cradle. Suggested to be programmed outside the tire, and the protocol comes from the tool. So if your tool is not updated, you won't have the proper protocol. Clonable, very close to programmable, very, very close. Again, cloning only copies the sensor ID, but the protocol comes from the tool. Takes time, really the same as a programmable sensor. And then there's a multi-application sensor. This is just like VDO's or Continental's REDI-Sensor. The difference between this one and the OE is it has multiple protocols already in it. The ID's already there. But just like OE, it works out of the box. It saves time. You don't have to program it. It follows the OE procedure. So it's very, very close to an OE sensor. So the tools we use. Tools have many functions, and depending on brand and model, these can have very basic or extremely advanced capabilities. Most importantly, they trigger sensors. They record the sensor IDs and record the transmission or read the transmission so that we can figure out if that's the right sensor for that vehicle, if it's working, functioning properly. They're used to perform vehicle relearns. Key to do relearns on these vehicles. Additional capabilities like uploading to OBD or pulling trouble codes or tread depth gauges or testing key fobs, many different things out there that we can do with these. They also require updates, so make sure we keep them updated. My team and I visit many shops every year, and 8 out of 10 shops don't have their TPMS tool updated. And it just causes them extra time when they're working on a vehicle. Many TPMS tool companies offer free support, so use it. Here's just a quick example of some of the tools out there today, but to fully service TPMS, you must have a tool that has OBD capability. When you're triggering sensors, hang the tool downward. Avoid pointing it horizontally at the sensor, and this will reduce the possibility of triggering a spare tire or the opposite wheel sensor. The other key thing is to move sensors away from your work area. Take them out of your pockets, off your lift arms, off the toolbox, out of the car. Those winter tires that you put in the trunk or the back of the car or the SUV, don't do that while you're doing a relearn, because then we're not talking to 4 sensors, we're talking to 8 possibly. Move those away when we're doing relearns. Continental has 2 tools now. I won't spend a lot of time on this, but TPMS D, all makes, all models with diagnostic and service capability. The FE services all makes, all models. Let's talk about relearns real quick. We use the tools to diagnose and perform relearns. It's strongly recommended and of great importance for vehicle owners' safety that following the installation of any replacement sensor or tire rotation where sensors are relocated, a servicing shop should follow the vehicle manufacturer's recommended relearn procedure. It is required to remove previous pressure values, and it's set forth by the vehicle manufacturer. It removes old data that might be there, old pressure values, diagnostic trouble codes. It ensures whether the system is fully functional or not. Right then, when you're doing it, you know the relearn's done, the car is done properly. It establishes the correct tire location, pressure, and pressure reading to the driver. You do a tire rotation, many vehicles can't learn that location by themselves. We have to do the relearn. And it's required when there's a change in pressure, even on some models now. And if we bypass this or don't do the relearn, we may be violating the make in operative provision, because now we've sent a vehicle out and the pressures on the dash are wrong. They're not shown in the right place. And if a person needs to fill up a tire and they see the left front's low, they go put air in that tire, but we rotated it and it's somewhere else on the car. Now they've overinflated a tire and they still have an underinflated tire. And on some GMs prior to, I think, 2010 or 12, the light was illuminated for high pressure and low pressure. So we would never know which tire or what's going on. So we have to make sure we follow these relearn procedures. 25% of the vehicles on there use a trigger from a tool and they use some sort of relearn mode. The vehicle goes into a mode. 35% connect to the OBD. Still require a trigger from a tool, but then you upload it via the OBD2 port. And then 40% of the vehicles can learn new IDs by driving. It's automatic. But many of us in shops can't drive the vehicles, or we don't have the time. Jaguar, for example, their relearn procedure on some vehicles is leave the vehicle sit for 15 minutes, drive it for 30 minutes over a specified mile per hour or speed, and then leave it sit for 15 minutes. That's an hour of labor just to do that relearn automatically. When on most vehicles, we can use that middle one, which is OBD. So it's either the trigger at the top or OBD, and that covers just about every vehicle out there. Auto relearn's great, but sometimes we don't have the time. And if we let the customer leave with it, if it doesn't complete or doesn't work, then they come back to the shop, and we could have just done the OBD2 relearn. So not all vehicles can do OBD, but most can. And indirect systems, like I said, have some kind of a reset rather than a relearn. So the types of direct systems. So here's an example of a simple system with no localization. During a relearn, it's stationary. Sensors are triggered and the vehicle stores the IDs. This could use potentially any of the three relearn types, trigger, OBD, or auto relearn. However, most are going to be trigger or OBD. Pressure is then received from the sensor and checked against the threshold. Since it doesn't have localization and only a telltale light, there's no indication where the fault is. It's just going to show us the light and maybe tell us that there's a low tire. Even though there's no localization, this type of system still must have a relearn procedure performed. We don't want to get into the habit of not doing relearns or guessing what type of system is in a vehicle. Here's an example of a little more advanced. It's a GM Ford trigger type. Many of you have probably done this. It's commonly used by Ford and GM. Vehicle stationary. This specific procedure uses a sequence of commands from the technician. So a key cycle, a key fob press, headlights in a certain cycle, and you've probably heard of them all. There's many. And just so you know, GM has over 20 of those relearn type procedures for these vehicles that they have. But during a relearn, sensors are triggered and the vehicle stores the IDs and location. Basically, you're teaching the vehicle the sensors and their location, and you follow the directions on the tool. Typically, all vehicles out there start with left front and go clockwise. Honda does have a few that start with left front and go counterclockwise. Now the sensor IDs are known by the vehicle. It's possible that this type of system can display pressure by position. And pressure received by the sensor is displayed and checked against the threshold. And if one of them is low, you will see that illumination there. If one of them fails, you might see this. But this type of system must have a relearn performed, or the pressure by position could be displayed incorrectly. Another type of advanced system, and these are all from Continental. We don't have names for the other ones. It's very common they're out there, but this one is called, uses low frequency initiators. They're mounted in the four corners of the tire or of the vehicle. Newer technology allows these two components to be combined as one, but they're located usually in front or behind the vehicle's tire in the wheel well area. As an example, this vehicle starts driving. The vehicle then says, hey, I need to do a relearn. I need to learn where my sensors are. The system sends signals to the low frequency initiators one at a time. So every time it sends it, it gets a response to the receiver from that sensor that it told to do something, basically wake up. And then the receiver says, hey, I just received this ID. So now the vehicle knows, for example, the left or rear. Okay, I'll store that ID in the left rear. It does the same thing for the other 3 locations. Okay, this type of system now knows the locations. It can automatically learn the IDs and store them automatically. We rotate tires, we change sensors. As long as you have the right sensor for that vehicle, this can be done automatically. Again, you can do an OBD2 relearn on this, but this one is pretty flawless. It works, but it requires driving the vehicle for a specified amount of time. Another type of Continental system is called Lock Sync, LSE, Location on Synchronized Emissions. It's a Continental system that uses the RF transmissions of the sensor at specific angles and correlates them to the speed pulse. The components of the sensor allow us to have them send information at a specific angle, and the vehicle data can reference the speed pulse information of each wheel at that angle. With complex algorithms and software processing, this vehicle can automatically learn the location of each sensor. A little more detail on this. The sensor transmits always at a fixed wheel angle position. Wheel sensors deliver the position for each wheel. After a few complete wheel turns, the TPMS sensor transmission fits only to one wheel due to its fixed mechanical connection of the wheel speed sensor and the TPMS sensor sending a signal at a specific angle. There's a lot of software processing in here, but you don't need that extra initiator or a module or an antenna in the vehicle. It's just a wheel speed sensor, the sensor in the tire, the TPMS sensor, and then some software processing. You have to drive this to have this happen, and it is best driven with a lot of turns, because that gets your inner and outer wheels spinning at a different rate and makes this change happen a lot quicker so that it can learn the locations. Again, learns all the sensors automatically, their IDs and locations. We have another one called Localization, which stands for Localization with Passive Start and Entry. This is another Continental system. We have low frequency antennas now located in driver's door, passenger's door, and the trunk. For example, here, to save on time, I use 2 locations. Still does the same thing if we use the passenger door handle as well. But once the vehicle is in motion, the system receives data from sensors A and D, receives sensor data from B and C. And as you can see here by the example, the driver's door will pick up A and D. So we can determine which sensors are on the left. So then the receiver says, well, there's 2 other sensors. So the vehicle says, okay, A and D are on left, B and C are on right. Now tell me which ones are in the front and rear. Well, we can determine that C and D are in the rear, so we know by default A and B are in the front. This uses sensors in the tires, has to be in motion, but now we're using modules that we use in the vehicle anyway for passive entry. Again, can automatically learn the location of all these sensors. So some quick industry tips and best practices. Hyundai and Kia, they have low line and high line. High line shows the driver positions and air pressures of the tires via a display. Low line does not communicate position, only will utilize the TPMS telltale. Some model years switched mid-year, so be aware of the type of system you are servicing. Sometimes as technicians, we have to look at the dash and see if it has these capabilities. Because on some of these Hyundai Kia vehicles, depending on the platform or the level of options, it could have come with low line and high line, and sometimes they use a different TPMS sensor. So we have to determine this before we call up and just say, hey, I need a sensor for this vehicle. Ford, the procedure listed in the owner's manual to perform after tire rotation on many late model Ford vehicles is just for rotating tires. It states to cycle the ignition to the on position with the engine off and then turn the hazard flasher switch on and off 3 times within 10 minutes or 10 seconds. Sorry, 10 minutes. It's 10 seconds. This procedure is to relearn new tire positions after tire rotation only. It will not learn new sensor IDs. You must follow the relearn procedure to learn IDs. This one, again, is only for tire rotation. We get so many calls on this from shops that their tool recognizes a sensor, but the horn isn't honking on the vehicle. That's because the sensor's transmitting, but the vehicle will not learn new sensor IDs. We have to do the TPMS relearn procedure, not the tire rotation relearn procedure. Stuck in a loop? Failed OBD learns are not uncommon on some Toyota vehicles, but they can be avoided. Many of those vehicles are equipped with a tire pressure set switch that's utilized for setting the baseline. When the button's pressed and held, it looks for sensors. It waits for the transmission of those sensors. And if we have a missing sensor, something's wrong with the sensor, the vehicle keeps hunting for that ID. It will not find it. It will not find it. So TPMS tools have a unlock ECU option on them. They have the software to reset this or clear that problem so that we can start over and do the relearn on these vehicles. Another Toyota thing they have a main second switched. It's used on some Toyota and Lexus vehicles for a second set of wheels like winter or off-road. It's usually located under the glove box. And depending on the tool you use, you may need to make sure the switch is in the main position when doing the Toyota OBD relearn. Check with your tool manufacturer for specific instructions. But there are tools out there that will not do the relearn in the second location for that switch there. Nissan, very common. GPS signal loss while in a garage during a relearn can keep pressure from position from being displayed. Move the vehicle outside so there's a clear view of the sky. And while we're on this topic, many vehicles require driving for pressure values to display. So you won't see them in the shop. You might have to drive to get it to display. So stepping back real quick to the types of direct systems, this is a tip rather than how a system functions, since Continental does not manufacture this type of system. This tip involves the use of wheels other than normal valve stem sensor mounting. For example, they mount on the inner side of the wheel rather than the outer, which I'll show you in a second. But it is a direct type system referred to as wall. It's used on many of these models of these vehicles here. With a wall system, once the vehicle's in motion at a specific speed determined by the manufacturer, the receiver can determine which axle of the sensor or which axle the sensors are located at, front and rear. And then it can also determine left and right, but it uses signal strength and rotation. So what can happen here is in this type of picture, which is common for some aftermarket wheels, we want them cosmetically to look nice on the outside. So let's put the sensor on the inner side, or the stem on the inner side. Causes problems on this type of system. And this system has been in use from 07 still through 2020 on those vehicles I showed you, and it probably will go beyond that. So here's how they would originally be mounted right here. You can see the normal mounting of the sensors, and I've displayed the sensor with a rounded edge and then an arrow showing you the direction of rotation. But this makes it easier to see what happens when you put those types of wheels on a car like this. So now we've mounted this sensor in this wheel, and if you notice, it is opposite, rotating opposite than what it was originally. We're not going to see a difference or anything. It's still going to transmit the information. But what could happen is, if this was a vehicle that uses, and it is this type of vehicle that uses this information, what happens is those pressures are switched. Won't turn on the light, won't do anything. So now we don't know which is proper pressure. The driver will never see any indication. They'll never notice a difference. But if you have a low tire, it possibly could be on the other side. That's just a tip from us. We don't manufacture that type of system, but it is out there. It's called WAL, Wireless Auto Locate. It's very common, works very well. It's just something you have to be aware of. Some examples of what not to do. Strap a sensor on and have another one next to it. I'm not sure what they were doing here. Or all 4 sensors strapped into a wheel, put a tire on it, air it up, throw it in the trunk. Or a PVC pipe pressurized with sensors, throw it in the back seat or in the trunk. And then duct tape. It's not as strong when it's seeing 70 Gs pulling on a sensor, ripping it right out of the drop center of that wheel. So enhancements and the future. So we have now selectable tire fill alert, tire fill assist, tire fill alert, easy fill alert, trailer TPMS, tire temperature and pressure monitoring system, tire pressure information system. These are just some of the new acronyms that technicians and drivers are going to need to know going forward, and there's probably more coming. And as far as tire fill assist goes, or TFA, there are 4 different systems out right now. Honda Acura uses one, GM uses one, FCA, and Nissan Infiniti. TPMS with a tire fill system is a visual and audible alert system to help customers properly inflate their tires. We still should look at the Placard, but this is something that OE manufacturers are really seeing that the customers like. So now they're putting it all in all these cars. They all operate differently, but they have very, very similar characteristics. While inflating, they give an audible or visual indication. When you hit the correct pressure, you get an audible alert, maybe 2 or 3 horn honks, and a visual indication. The hazards flash on and off. And then if you go over, you might get multiple audible alerts or a different change in the visual indication. But they're all operating very similar. Advanced capabilities. Here's that ETIS sensor. In addition to standard functionality and benefits of our TPMS system, this could give us even more information, like advanced tire information, information about the tire. It's simple, it's standardized. It installs directly the inner liner of the tire, and it could be mounted directly in from the date or something like that. Again, could be no OE or aftermarket uses this in the US, but it is used in the aftermarket in Europe. It is a real product. It's just not being used yet by OE. It is being used by commercial vehicles, however, though. Can be easily activated with the TPMS tool, just like what we have today. But one of the key things is one size fits all, because it doesn't matter what size the valve stem is or how it's mounted. It mounts to the inner side of the tire. It can give us load changes, alerts, different things like that, overload, increased safety then. It has the ability to measure tread depth, temperature, tread wear, additional cost savings, optimized tire life, and reduced fuel consumption and CO2 emissions. And from this, we can also get what's called a hydroplane warning system. Again, a real system that Continental has. Cameras are the key early warning to this detection, though. The cameras now that we have on their side view mirrors can recognize a splash or a spray pattern from the tires. And as a vehicle hydroplanes, that pattern changes. This could be the key to saying, hey, you need to look at the speed of the vehicle. And this is the car basically telling itself, because we have adaptive cruise control now. Autonomous things are going on in these vehicles. And so then it pulls information from the sensors in the tires and says, hey, what's going on? Is there water in that tread? Do we have worn out tires or a risk of hydroplaning from, no tread or low tread, whatever it is? It's especially important for autonomous vehicles because a lot of these systems are doing things on their own now. For Continental, this type of system is another step forward to our Vision Zero, traffic without accidents. So what we need to remember is test before we start any work. Verify model year by VIN number. Don't use that build date. We want to go by VIN. Visually inspect the stems, the hex nut, the seal when it's equipped with TPMS. Look at that telltale mill every time the customer brings that vehicle or you bring that vehicle into the bay. Document whether it has TPMS and note the status of that telltale or mill. So many technicians forget to note the status, and then you get all done and the light's on or it's flashing and you can't remember what it was doing when you brought it in. Just note that status. Many companies are requiring them to write down, does it have a TPMS light on, off, flashing, whatever it is. And inform the customer. Many of us now have to inform the customer of different things on their vehicle. TPMS is one. If we inform them that, hey, you've got 4 sensors on this car, one of them's bad, they last 7 to 10 years, your car's 8 years old, it might have 80,000 miles on it, you have one sensor bad, the other 3 can probably go bad. Do you want to change all 4 or just one? It doesn't matter what they do at that point. What you've done is let them know that there's other sensors on that car. If we don't let them know there's other sensors on that car and they leave and another sensor fails, they're immediately going to think that the work you did has failed now. So then they're going to come back, excuse me, and say, hey, that sensor you put in is not good. No, it's actually another sensor and you're going to have to do it. Now they're upset. So we need to inform them of the number of sensors and their lifespan. Have a reliable source to get the sensors. Get familiar with shop tools and products. Know how to use that tool that you have there. Know who to call for troubleshooting. We have a tech helpline and many other companies, TPMS tool manufacturers all have that. When a relearn is started, vehicles only want one sensor talking at a time, the one you trigger, not the one in your pocket or in the car or on the lift arms, one at a time. And most of those systems are smart enough to realize something's interfering. If you work in a dealership where a lot of like vehicles pull up, their chances are of getting information, crosstalk, different things from those vehicles. So most of the systems are smart enough. And read that tool. If it says 0 PSI and you're triggering a sensor at a tire that has 30 some PSI in it, you picked up a sensor from somewhere else. Figure out where that is. Make sure you look at that tool. Use that tool. It's a key component to doing your relearns. That's why it must be updated. And do not get frustrated. That I know can happen. It is very frustrating. We have REDI-Sensor.com. A lot of information there. Part lookup, relearn procedures, product knowledge, videos. Our tech line is 1-800-265-1818. It's printed on every box. It's on REDI-Sensor.com. It's there for you to use. And my name's Sean Lannoo. There's my email. I have Denzel Law, who's a technical training specialist, and Alan Selzler, also a technical training specialist. You can contact any of us. Again, REDI-Sensor.com or ContinentalAftermarket.com. Thank you very much.
Thank you, Sean. Great job. Okay, momentarily, we're going to go over to Dan Baumhart while he queues up some of the questions out of the question pane. I just want to make a quick public service announcement is that, first of all, ASE test centers are beginning to slowly reopen. There is more availability on a daily basis. For more details, go to ase.com and look under the registration information and the test center location. Also, I stated it at the beginning of this webinar, but I'll reframe it again here. Those of you who've been asking about certificates, allow 1 week for your certificate to come automatically by email. There is a little bit of post-event processing that we need to do, so please be patient with us. With that, Dan, what do you got?
Thanks, Dave. Sean, first thing I'd like to bring up, Rufus and Frank asked some questions about nitrogen. Rufus wanted to know if it's true that nitrogen can extend the life of the tire pressure monitoring sensor. And then Frank asked if using nitrogen instead of compressed air, is the 1 PSI loss per month and or the 10 degrees temperature change less when you do that?
To start off with the first part, can it extend the life? I'm sure it can. It's not going to be that big of a difference. Probably not a measurable difference, but it could extend the life of the sensor a little because it is cleaner. It would depend on how much moisture and different things that could be in your compressed air. But again, it's not a huge measurable difference. And then to go on with your PSI loss over time or with temperature changes, nitrogen is, 70 whatever percent oxygen anyway. Yes, it's going to be a little cleaner, but we have natural pressure loss with rubber. It's just natural. So again, probably not a huge measurable difference. Like, okay, maybe if we lost exactly 1 PSI for 10 degrees, maybe we lose 0.75 PSI for every 10 degrees. It's not going to be a huge amount. The molecules are different. It is different, but again, not a huge measurable difference.
Okay, and then there's from Gabriel. He asks, early on in the presentation, you were discussing the pressure placards and that they're mounted to the driver's door frame in 08. Are manufacturers still able to put them in the gas door and the driver's rear door jamb?
Yeah.
The driver's
rear
door? Okay.
Yeah, no, that started actually, it was mandated, the TPMS was mandated in 08, but placards started going in the door jambs, I want to say 02, 03 timeframe. But yes, you will see them still in many other places. The owner's manual, the fuel door, sometimes in the visor or on the jack, or how to change the tire or the spare tire, different things like that. So it can be anywhere else. It must, though, be in the driver's door area.
And then Mark asks about balancing beads. Some of the tire shops are using those to provide a good balance with a vehicle's tire wheel assembly. Are they safe with the TPMS sensors?
They are safe, but again, if they get into that hole, if they're small enough, they could plug the hole. Now, most of the holes are on the top side of the sensor. So I don't know if you can see this, probably, but there's your hole right there. It's mounted like this. So when it's spinning, it's going to do this. The tire is up here. Centrifugal force is going to bring those balancing beads up away from the sensor. So could something happen? Anything can happen, but the chance of them happening is lower. But if one gets in that hole and gets stuck there, we could have a problem. I have seen where moisture and oil make you sticky inside the tire, and then you could see a problem. You can't really say, because it's not physically going to damage the sensor, but could it plug the hole if it got there and stuck there? Yes, it could.
And then several attendees, Michael, Sean, they've asked about if there is a good chart out there to identify what vehicles are using what type of sensors. Do you know of anything available at all to solve that need?
Well, the Tire Industry Association has a nice flip chart book that you can purchase. We have our website, REDI-Sensor.com, which has all the applications. It doesn't show OE sensors, but there's also DILL Air Controls, DILL Air Controls. Their site has information on OE sensors and aftermarket replacement sensors and relearn procedures. So there's different avenues to find it. If you need specific help, email me. I have no problem helping. But DILL Air Controls and the Tire Industry Association are two good places, as well as REDI-Sensor.com.
And then Joseph and several others have asked an installation question. So they're not extremely familiar with the snap-in style sensor that would be used in place of the typical TR14 valve stem.
Right.
Is there lubrication involved in there? Do you use a valve stem installation tool on those? Things like that. They're asking about the service side of it.
With a standard rubber stem snap-in type sensor, you pull it through just like you do a valve stem, exactly the same way. There are some sensors out there that maybe you don't have the sensor on when you pull the valve stem through. It's done in two pieces, but it's similar to pulling a regular valve stem through. And then the metal style is clamp in. You unscrew the nut, slide it through, hold it in position, and you torque that nut to the specified torque spec.
Okay, and then Christian asks about heavy duty vehicles. Do you know if the TPMS systems are on commercial vehicles now, or if there's a mandate for those yet?
I can't say that there's a mandate. I know the dates, or I know that's been pushed around and talked about, but there is no, as of now that I know of, no mandate on commercial vehicles.
And then Edwin asked about discussing liability with the customer when replacing or removing TPMS sensors. He says that because they really are considered a safety component on the vehicle, and he wants to make sure that customers, that as a technician or a shop, that the customers know some of the problems related to TPMS and proper servicing.
There's many different charts out there, different information. you know, it is a mandated safety item. There's props you can use in your shops to talk to customers. These are available through your tire suppliers. It has notes for technicians on the back. We have another chart here, a pop-up chart that talk to the customers and tell them, you know, what it is, what the components do. So, I mean, we have to inform them of what the system is. And I know it's difficult. You know, there's money involved and people don't want to pay to have their vehicles fixed, but we're just there to make their vehicle, repair their vehicle back to the way it was from the factory. So we have to learn how to explain these things. Again, REDI-Sensor.com, ton of information on how to talk to customers and different videos you can show or watch for yourself on educating the consumer on this type of system.
Sean, the questions pane was full of thank yous for a fantastic presentation. Job well done. Thanks, folks, for participating by sending some questions in to us to keep the engagement going. We appreciate that. I'm going to pass this over to Dave Kappert.
All right, Dan, thank you. I appreciate it very much. Thanks to Sean Lannoo from Continental Corporation for this look at TPMS from a 2020 perspective. The details covered here today certainly reflect that technology does not stand still. This webcast was brought to you by ASE and the ASE Education Foundation. For announcements about upcoming sessions, keep an eye on your email inbox. On behalf of Sean Lannoo, Jennifer Holland, and Dan Baumhart, I'm Dave Kappert, and this concludes today's webcast. We hope to see you online at another event soon. So long, everyone.